In fluid mechanics, pressure head is the internal energy of a fluid due to the pressure exerted on its container. It may also be called static pressure head or simply static head. It is mathematically expressed as where is pressure head, is fluid pressure, and is the specific weight, is the density of the fluid, is acceleration due to gravity. Note that in this equation, the pressure term may be gauge pressure or absolute pressure, depending on the design of the container and whether it is open to the ambient air or sealed without air. Practical uses for pressure head. Fluid flow is measured with a wide variety of instruments. The Venturi meter in the diagram on the left shows two columns of a measurement fluid at different heights. The height of each column of fluid is proportional to the pressure of the fluid. To demonstrate a classical measurement of pressure head, we could hypothetically replace the working fluid with another fluid having different physical properties. For example, if the original fluids were water and we replaced it with mercury at the same pressure, we would expect to see a rather different value for pressure head. In fact, the specific weight of water is 9.8 kilonewtons per meter 3 and the specific weight of mercury is 133 kilonewtons per meter 3. So, for any particular measurement of pressure head, the height of the column of water will be about 13.6 times taller than the column of mercury would be. So if a water column meter reads 13.6 centimeters H2O, then an equivalent measurement is 1.00 centimeter Hg. This example demonstrates why there is some confusion surrounding pressure head and its relationship to pressure. Scientists frequently use columns of water to measure pressure, since for a given fluid, pressure head is proportional to pressure. Measuring pressure in units of of mercury, or inches of water makes sense for instrumentation, but these raw measurements of head must frequently be converted to more convenient pressure units using the equations above to solve for pressure. In summary, pressure head is a measurement of length, which can be converted to the units of pressure, as long as strict attention is paid to the density of the measurement fluid and the local value of G. Implications for gravitational anomalies on, we would normally use pressure head calculations in areas in which is constant. However, if the gravitational field fluctuates, we can prove that pressure head fluctuates with it. If we consider what would happen if gravity decreases, we would expect the fluid in the Venturi meter shown above to withdraw from the pipe up into the vertical columns. Pressure head is increased. In the case of weightlessness, the pressure head approaches infinity. Fluid in the pipe may leak out of the top of the vertical columns. To simulate negative gravity, we could turn the Venturi meter shown above upside down. In this case gravity is negative, and we would expect the fluid in the pipe to pour out the vertical columns. Pressure head is negative. If and, we observe that the pressure head is also negative, and the ambient air is sucked into the columns shown in the Venturi meter above. This is called a siphon, and is caused by a partial vacuum inside the vertical columns. In many Venturis, the column on the left has fluid in it, while only the column on the right is a siphon. If and, we observe that the pressure head is again positive, predicting that the Venturi meter shown above would look the same, only upside down. In this situation, gravity causes the working fluid to plug the siphon holes, but the fluid does not leak out because the ambient pressure is greater than the pressure in the pipe. The above situations imply that the Bernoulli equation, from which we obtain static pressure head, is extremely versatile. Applications. Static. A mercury barometer is one of the classic uses of static pressure head. Such barometers are an enclosed column of mercury standing vertically with gradations on the tube. The lower end of the tube is bathed in a pool of mercury open to the ambient to measure the local atmospheric pressure. The reading of a mercury barometer can be converted into an absolute pressure using the above equations. If we had a column of mercury 767 mm high, we could calculate the atmospheric pressure as a eurocent, 133 kilonewtons mar cubed equals 102 kilopascals. See the Torr and Pascal articles for barometric pressure measurements at standard conditions. Differential. The Venturi meter and manometer is a common type of flow meter which can be used in many liquid applications to convert differential pressure heads into volumetric flow rate, linear fluid speed, or mass flow rate using Bernoulli's principle. The reading of these meters can be converted into a differential, or gauge pressure, using the above equations. See also, pressure measurement, derivations of Bernoulli equation, hydraulic head or velocity head, which includes a component of pressure head, Venturi effect, references. External links, Engineering Toolbox article on specific weight, Engineering Toolbox article on static pressure head.